Find the equation of the line tangent to the curve y equals 6x at the point pi over 6, 3. What is the equation of this tangent line in the form y equals mx plus b? Okay, so to find a tangent line, there's always two steps. We need to first find the slope of the line that we need by plugging the point of interest into the derivative. And it's the x value of the point of interest that we need to plug in. Now, sometimes this is already done, but the next step is often to make sure you also have a y value. In this case, that's already happened. So plugging pi over 6 into the original function was already given as 3. So you don't have to do that step if it's already done for you. And the last step is to plug into y minus y1 equals m times x minus x1 in order to create the equation of a line. So we need a slope at point x and y, so we can plug into this equation. So let's work on the slope then. So the derivative here, so y prime, the derivative of 6 sine x will be negative 6, sorry, my bad, positive 6 cosine x. So it's easy to get confused there. The nice thing is sine and cosine just flip-flop when it comes to derivatives. It's just sometimes difficult to remember where the negative goes. But keep in mind, the derivative of all cofunctions is a negative. So this is the derivative of sine, so it's the sine, so it stays positive in this case. It's unfortunate of that language there. All right, so the slope of this tangent line is going to be the derivative of my function evaluated at pi over 6. So this would be 6 cosine pi over 6. Now, you might be rusty on how to evaluate things like sine, cosine, tangent, your different trig functions around the unit circle. You don't have to be a wizard at this. All you have to do is be able to have a process that you can accurately do this for at least quadrant 1. Because if you can do quadrant 1, you can always work your way around and figure out the rest of the quadrants. All right, so I feel like you should always have memorized the different values of sine and cosine for quadrant 1, but if you don't, take a minute to work it out. Don't just randomly guess. So let's see. If I had a point on a unit circle on the x-axis, that would be 1, 0. And remember, all points here are of the form cosine x, which is the x1, my bad, and sine x, which is the y1. All right, so then up here would be 0, 1. Along the 45 is square root of 2 over 2. That's the easy one. All right, and then you have here and here. So this angle measure is your 30 degree, which is pi over 6. This angle measure is, of course, the pi over 4. And then this angle measure here is pi over 3, which is the 60 degree. And just, if you can't remember those, just think of pi as 180. So 180 over 6 is 30. 180 over 4 is 45. 180 over 3 is 60. So that's an easy way of getting them. Now, we just have to know these points right here. Well, the thing to keep in mind is that this particular point right here is further in the x direction than it is up. And the coordinates of this point are going to be 1/2 and root 3 over 2. Those are the remaining values. You just have to remember which one is which. Well, root 3 over 2 is bigger than 1/2. So you go further in the x direction, so that's going to be the longer value. And then you go shorter in the y direction. And this one, you don't go as far in the x, so this one's 1/2, and then you go up further in the y, so root 3 over 2. So if you need to fill something like that out, There's no shame in it. That's perfectly fine. The most important thing is have a way of determining these values. So anyhow, 6 times cosine pi over 6, that's going to be this value right here, root 3 over 2. 2 goes into 6 3 times, so that leaves me 3 root 3. Okay, now I think I'll section off here. Y minus y1, which is 3, equals my slope, 3 root 3, times x minus x1, which is pi over 6. So y minus 3 equals 3 root 3x minus 3 root 3 times pi over 6. And what's nice is the 3 goes into there twice. That'll simplify a little. So y equals 3 root 3x minus pi root 3 over 2 plus 3. And there's not much you can do to combine those. Like you could get a common denominator if you prefer, but this really is just a perfectly fine form. It's algebraically equivalent to the tangent line, so that's all you need.